Hi. This time I'm going to show you how to trace machine code that you create with help of assembly language. For this we need an additional tool, a debugger, and we are going to use a very popular one, OllyDbg. You can get it from this website, so let's just download it. And unpack it as usual. One important option that this debugger has is so-called just-in-time debugging. I have it set up already, but when you run it for the first time, you may need to set it with this button. What this option does is that whenever a program crashes, Windows is going to launch this debugger and allow us to trace it from the point of crash. This is going to be quite helpful when writing some code in assembly language, so let's try it. Let's write a simple program that would crash. We need format PE to create a Windows program, and then even a single instruction might be enough. For example, interrupt free. This is a breakpoint instruction. You would normally use it while debugging to stop the program at a specific point, but this instruction should not occur in normal execution. So when we just run this program normally, it is going to crash immediately. So let's try it. Save the program as test and assemble and execute. And we have the crash, and as you can see, the debugger has been launched. Let's have a closer look. We are at the breakpoint instruction, and we had no more instructions in the program, so this is just zeroed memory, but as you can see, even zeros have some meaning to the CPU. So if we tried, it would try to execute even these bytes as some instructions. But to keep experimenting, let's try to write a program that has some interesting instructions in there. So let's add a few instructions. First, let's write 0 to EAX with move instruction. Then we have the breakpoint. We can modify EAX again with another move, and then perhaps modify it once more with increment instruction. And let's run it and see it in debugger. So as you can see, we are now at the breakpoint, and EAX register is already zeroed because move EAX 0 was executed earlier. And now we can step over the instruction with F8 key. So let's try it. We are now ready to execute the move EAX1 instruction. So let's do another step. The instruction has been executed. We now have 1 in EAX. As you can see, the debugger colored it red to indicate that the value has changed. And we can do another step to execute the increment instruction, which increments value of EAX by 1. And the value is 2. So this is how we can simply trace the instructions and see what they do. Now there are two different options for stepping, F7 and F8. And I'm going to do one more experiment to show the difference between the two. So let's write some subroutine and call it here. Call it twice so that we can experiment. The subroutine is going to just increment register and return to the main program. Let's put a nope here so that we can see when we return where we are. And let's go back to debugger. Now, if we use F8, step over, then we are going to just step over an instruction to the next one in sequence. So when we step over this call, the entire subroutine is going to be executed, and we are going to continue to the next instruction that comes after this call. So to the second call. Let's try it with F8. As you can see, EAX register is now 1. It has been modified by the subroutine. And we are ready to execute another call instruction. But this time we are going to do this with F7 key, which instead of stepping over to the next instruction in sequence as seen here, it continues to the next instruction as seen by CPU. So when we execute call instruction, the next instruction that CPU executes is inside that subroutine. So we, in fact, with F7 we enter the subroutine. So we are now inside the second call. EAX is still 1, but we are about to execute increment instruction and return to the main code. We are back. So this is the difference between F7 and F8. And in general, this is how you can easily trace and see what the instructions that your program contains do. I hope this is helpful, and thank you for watching.